Hi, this is Irv Shapiro with Make with Tech. And for the past 4.5 years or so that I've been making videos about using technology to be a creator, a maker for DIY projects, where I've covered well over a dozen, maybe close to 20 different variations of 3D printers. I've been looking for that ideal 3D printer that's very easy to get started with, but would grow with you easily. And while I found some remarkable products that allow you to get there, they often require advanced modifications, replacing major components. So today, we're going to look at a 3D printer that is exceptionally easy to use, yet has the potential to print very complicated models using a variety of materials that are normally not approachable with entry-level printers. So if you want to learn more about the new Ankermake M5C, stay tuned and let's learn something together. Here at Make with Tech, we help people learn about technology in everyday language without a bunch of complicated stuff. I've done a lot of videos on 3D printing, a little bit on electronics, a little bit on software, a little bit on woodworking. And today, we're going to look at a product that might really have the chance of changing the world of entry-level, hobbyist-focused, and really small business, educationally focused 3D printing. And part of the reason is that Ankermake, the manufacturer of this product, is a division of Anker Innovations Technology. And many of you might know about Anker because, as an example, I have a spare battery for my phone that they made. Well, they also have a number of other brands. I was surprised to learn that the headphones that I use are also made by Anker. So Ankermake is a large company, a $1.5 billion or larger company. Now, why is that relevant? The majority of 3D printers are made by manufacturers that were created to make 3D printers. Two names people may recognize if you've been in the market for 3D printers are Prusa and Creality. Both started for the purpose of creating 3D printers. Well, Anker is different. Anker is a billion-dollar plus consumer electronics company. That means a number of things. It means they have very deep engineering expertise. They have a very good distribution network. That means the ability to sell their products around the world. They've had to deal with consumer support for a long time. And in fact, I reviewed their first 3D printer, I don't know how long it was, 3, 4, 5, maybe 6 months ago, which was the Ankermake M5. Now, the Ankermake M5, if you look back at my review, I thought was a very good printer. A little bit pricey for what you got, but really an excellent printer. And to be honest, it's the printer I use every day now. When my grandchildren come over and they want something quickly, I use my Ankermake M5. So I was intrigued when Anker reached out to me to do a review of the M5C. And at the time, I didn't really know where it was going to fit. The review is being done under NDA, so I'm filming portions of this before the printer has even been released to the public. And this unit here is a pre-release model. That means some things might not be identical to what you'll see if you buy one in the future. It's also interesting that this is an entry-level 3D printer, meaning it's targeting beginners Yet it has many, many things in common with, and you can actually see over my shoulder here, the M5. Overall, many of these things are slight reductions in capabilities. It's slightly smaller. It has a single belt driving the bed back and forth. That's called the Y-axis. But at the same time, it has things that are a significant improvement. This has an all-metal hot end. What that means is it can be used for both traditional consumer-grade filaments, PLA, but it can also be used for more industrial filaments such as PETG, because this hot end can go to 300 degrees Celsius, whereas the original M5 was rated to 260 degrees Celsius, and to be honest, folks had some trouble when they were pushing that temperature. Now we're going to take a look at the Ankermake M5C and answer the question of, should this be your first 3D printer? Now before I get started with the overall characteristics, the specifications of this printer, I want to disclose that Ankermake sent me this printer at no charge, along with a couple reels of Ankermake filament, in order to facilitate this review. Let's begin with some specifications. And if you're new to 3D printing, some of this stuff won't make sense to you at first, but it's sort of something you have to start every review with. So as I mentioned, the list price of this printer is going to be $399. It has a intro pricing of $359. And just like its big brother, it will be available via a number of distribution networks. Here in the United States, you can buy one of these on Amazon and get it the next day. You also can buy some of the consumables, the nozzles and the silicone sleeves, some of the parts, not all the parts, but some of the parts if you need them for this printer. It has a print area of 220 millimeters by 220 millimeters by 250 millimeters. That's slightly smaller than the M5. It is blindingly fast. It can print at a slightly reduced quality at up to 500 millimeters per second. Let me put that in perspective. The standard print speed of a Creality Ender 3, even the Ender 3 S1, starts at about 50 millimeters per second. That's 10 times faster. In general, you can print at 250 millimeters per second with very, very good quality. It uses standard size nozzles and standard size filament. That means the filament is 1.75 millimeters in diameter and the nozzle is 0.4 millimeters. You can use other nozzles for this printer. What's a bit remarkable is that in this price range, it has a number of relatively advanced features. It has auto bed leveling, where the nozzle is used to sense imperfections in the bed so that your print will stick properly. It is a direct extruder. That means that even though it has this tube here connecting to the filament, it's actually a set of gears inside this casing here that pull the filament through. That's a direct extruder, and it's an all-metal hot end. That means it can print it up to 300 degrees Celsius. It actually has two CPUs inside, one running the Marlin firmware, which is sort of the traditional firmware that's often used on printers of this style, and a different one running the communications. Because something that's very unique on this printer that's different than the M5 is you'll notice there's no touch screen. There's no screen at all. How do you communicate with this printer? Well, you communicate with this printer either from your computer or from your phone. But in fact, you must use a smartphone, perhaps you can use a tablet also, in order to set up this printer. Now, at first, that might strike you as inconvenient, but the user interface available on a smartphone today is vastly superior to what you've seen on the front panels on 3D printers. And I, at the end of the day, found it even better, more convenient than using a touch screen or a knob or some other control. There is one big button right here. I'll move this back so you can see it easier, that you can program for single taps, double taps, long taps to do a variety of things. I haven't really used that much. I just have been using my phone, which works great. The print surface is the same material as the M5. It's a PEI coated sheet. It's a textured sheet. It works really well. Every print I've printed to this has stuck. I was concerned that when I was printing these advanced materials, PETG, it would stick too well and pull some of the coating off. So I used what's called a bed adhesive from a company called Magic Goo, which I really like. I used the PA variant. All that means is it's sort of a liquid you spread on the bed that both helps your prints adhere to the bed, but also creates a separation barrier so when they cool down, this is a special stuff that's sticky when it's hot and not when it's cold. So when it cools down, it releases the print. So to set up this printer, you take the Ankermake application, you download it from your store that's appropriate for your phone. The first thing you're going to need to do is create an account. And it will prompt you through creating an account. And one of the interesting things about creating an account, and you can create the account either from the Ankermake application, or you can go to the Ankermake website and download their slicer, the component that prepares prints for the printer, and create it from there. When you create an account, it asks you for a region and actually displays a message that is addressing one of the issues people have with Wi-Fi connected devices. And while in the past, in full disclosure, they've had some challenges, now they put up a message saying that they'll be storing your data in your region as a way to address those concerns. This printer is not usable without a Wi-Fi connection, at least not for the initial setup. Once it's set up, you can use the button on the front and a USB key in order to print, because what will happen is when you press this button, it just prints the latest file on this key. But to set this up, you will have to create an account at Ankermake. Now, as part of the setup, there are two ways the app can find the printer. It's supposed to be able to find it via Bluetooth or by scanning a QR code that's on the back. I wasn't able to get the Bluetooth to work. Remember, this is a pre-release version, but the scanning of the QR code worked seamlessly. Now, the next thing you're going to need to do is you're going to need to load Filament into this printer. And the Filament connects from the top on a reel to a tube here. And for those of you familiar with 3D printers, it looks like a Bowden tube. It's not. It's just a guide tube. I'm not even sure why it's there, maybe to keep the filament from tangling. So what you do is you push the filament into here till it gets to the end, then you pull this little lever back and you push it a little more. Then you go into your application, and while you will not, and I'm actually going to turn on my printer now so that I can go into the application and follow the screens that I'm chatting about them, and you'll be able to hear the sound of the printer. The fans are actually a bit quieter than they were on the M5, but there's still, you'll hear them. On the other hand, it's about all you hear. Now, that beep told me the printer is fully on. So now I can go into my application, and since I already added the printer, I have a control panel right here in the application. And you can see that on the screen. Well, there is no load filament option here, but there is a retract and extrude option. So if I click on extrude, I'm actually going to get a message saying I have to heat up the nozzle first. And it will heat it up to 200 degrees Celsius. That's great for printing with the standard Ankermake PLA Plus or any other PLA. But if you want to print with more exotic filaments, then you should say no at that point, and you can literally click on the word nozzle that has a temperature above it, and you can put on your own temperature. And you'll see that right here. Now, once you've loaded the temperature and it's come up to temperature, you then can use the extrude function from the application. But what if it doesn't work? What if it feels like it's jammed? And I guarantee you, one day or another, you will have filament jammed in your nozzle. Well, that was one of the most pleasant surprises about this printer. I'm going to turn this here so it's a little closer. This little plastic cover comes right up. It just snaps right up. Once you've lifted the cover up, it makes it very easy to pull this little guide tube out. You press down on the filament guide here, and you can pull the guide tube out. Now, why would you want to do that? Well, by pushing the filament in by hand, pulling back this nozzle and pushing the filament in by hand, where you can get better pressure on it than pushing it in from here, if it's not already through the gears, you can often clear a jam. So to summarize that, just cut off a piece of filament, put it directly into the hot end, pull the lever back, heat this up, and press it through to clear out any jams or get it loaded. Now, once that's in place, you can just slide this tube back in. We can slide the cover down, and it would be easier if I was in front of the printer instead of off to the side. Slide the cover down, put the clip back together, and we are all set. And one of my concerns often with having a direct extruded printer for beginners is it's hard to clear the nozzle if it gets jammed. You have to unscrew a bunch of stuff. So having this cover that slides off is a big plus. Now, how do we go about starting a print? Well, once again, you go to your application and you have a couple options. You can click on Explore, and you'll actually see some models from Ankermake. If you click on those and print, they'll just start. It'll heat up the nozzle to the right temperature, they'll just start. They are all configured to print in PLA though. I have a more exotic filament in here right now, left over from my last print, so I would have to manually set the temperature. The other way you can print is you can slice a model, and we'll talk about slicing models in a minute. You can place it on the USB-C key, plug that in, and then you can start that from the application. And you'll see in the three panels to the right on this slide, you'll see the crystal generator listed twice, and that's because it was produced on a Mac and Macs put an extra file out there. But there's a G code file, that's what you select. Then you'll see a preview of the print. You click print, you'll see it's loading, and you're ready to go. So you do it all directly from this device. Now, while you're printing, you also monitor it from your smartphone. What if you get a model off the internet and it's not sliced already? How do you prepare it? Well, Ankermake supplies you with a proprietary slicer that's based on some open source software and their own modifications. But they also give you instructions if you're a more advanced user on their website for how to use the Prusa slicer or Ultimaker Cura. I actually thought the Ankermake slicer was very, very good. The current version of it appears to be Cura based. There's some discussion on the internet that they might be changing that in the future, but I found it very, very easy to use and complete for the majority of use cases. So you just go to the software area on the Ankermake site, you download it for your appropriate operating system. Now let me walk you through a couple of the steps here. So when you load in a model, this is what it looks like. The graphic presentation is really nice. On the right-hand side, you'll see we're in easy mode. If you click on easy mode, you have an option to go to advanced mode, and there you'll get most of the types of parameters that you're used to seeing in the Cura slicer if you're a more advanced user. When you load a model, you just select the filament type you want. You should start with PLA. They have PLA Plus listed, but you can also use that for regular PLA. And that's the Ankermake supplied filament, which I found to be very, very good. But I also used this printer with filaments from other manufacturers, and it worked equally well. Once you've selected those basic parameters, you click on Slice. And then you'll see this variant, and I've changed the colors a little bit to make it easier to see on the screen here. Normally, the print itself is in orange. You'll see this rendering, and by using the scroll bars on the right and the bottom, you can look at individual layers of your print. So this is what it looks like when you're looking at a layer of the print. You can also look at the print itself versus supports. Now, what are supports? Well, if you look at this print, you'll see there's some places where there's filament sort of hanging from his chin, some other places. That's because 3D printers are not very good at printing in thin air. If there's a layer underneath, you're printing a layer on top, they do a great job. They can print a short distance that's just a span, but if that span is too great, the molten filament will start to droop, and you'll end up with artifacts that look like this. To solve that, you turn on a feature. In the easy mode, it's called Global Supports. In the more advanced mode, you have the standard settings that you would have in Cura. In fact, you can see here what this model with supports holding up those areas that might droop would look like. Now, when you're ready to print, you either say export and you save it onto one of these USB keys. And it can be any USB-C key. It's not a particular brand. Or you click on print. If you click on print, the slicer will go out to your network and find your printer. You select your printer. I have 2 on my network. You click print, and it will go. That's all there is to it. Now, this is the print you saw being sliced in that particular example. It's a really beautiful print. The surface looks excellent. It's very difficult to see the layer lines, but there is a bit of stringing where this print needed supports, and I did not print it with supports. Let's look at some other prints that I printed with this. The first thing I printed was this rose that was in the application. So I actually found it in the application on the phone. It's a very, very nice print. The quality is good. There's a little bit of very fine stringing. What is stringing? Stringing is where you see fuzz or strings hanging from your print, which are caused by your printer moving its nozzle over an area where it's not extruding filament. Because that filament's still hot, some might droop out of the nozzle. So there's a little bit of minor stringing here, but overall this is a beautiful print. Next, I went ahead and printed a very difficult print. This is a print that fails on most entry-level printers, and it printed really well. On this printer, it succeeded. Now, you'll notice one of these towers is broken off. I broke that off when I went to grab it, and I wasn't careful enough. The only defect you'll see is some really thin cotton candy-like stringing on these top towers. Now, these top towers, because they're so thin, are very difficult for a 3D printer to print. In addition, you'll see there are holes down here. Well, these holes are actually pins that come out that are printed in the middle of the holes, not touching the walls, with various tolerances that range from 0.2 to 0.5 millimeters. All of the pins came out. Finally, you can actually measure the size of these towers here to verify they're correct, and they are very, very good. And you can check here And you can check over here to see if when you're doing bridging, that's printing the filament over an open area, whether it droops. This is one of the best versions of this print, this Kickstarter quality print that I've printed. But then I wanted to do both some standard things and some things that were more interesting. So I printed a 3D Benji that I sliced, and it came out extremely well. You'll see these as common prints on many printers. Then I switched to PETG. Now I used two different types of PETG filament. The first, and this is in a baggie because PETG filament is very sensitive to moisture in the air. If you leave it exposed for a long period of time, it will not print well. So this is from a manufacturer called Sunlu, S-U-N-L-U, and I purchased this right on Amazon. And this next PETG filament is from ColorFab, and it's the ColorFab XT filament, which is one of my favorites. Now, what's the difference between PLA and PETG, and why is it important to me to have a printer that can print in PETG? Well, PETG prints at a higher temperature. That also means that its glass transition temperature is higher. What is glass transition temperature? It's the temperature at which a material turns into like a rubbery consistency. It starts bending easily. Well, PLA generally prints at 200 degrees Celsius, and its glass transition temperature is, depending on the PLA, can be as low as 50, 60, maybe 70 degrees Celsius. That means if you print something, this happens to be a phone holder that goes into the cup holder in a car, so you can have your phone sitting next to you. Well, if I print this in PLA and I leave it in a hot car, now this summer there are a lot of cities that got very hot. In all likelihood, this will begin to droop or melt. Now, it won't turn into a puddle of plastic. Your car's not going to get that hot. But if this was, let's say, some type of bracket holding something up, it would probably bend and release the object. PETG prints at about 240 to 260 degrees Celsius. So much higher temperature, and its glass transition temperature is also much higher. So it's a better material to use for things that have to be in warm environments. It's also stronger, but its strength can mean a couple things in plastics. You have to look at the force at which it begins to bend and the force at which it breaks. So PETG is stronger than PLA in general. There are new PLAs that are special that might be as strong, but it's stronger in general. But once it gets to the point where it's gonna break, it doesn't really bend at all, it snaps. PLA does have the advantage that it sort of bends before it breaks, but it will not handle as much weight. So PETG is a wonderful thing to be able to use for a lot of use cases. Most consumer grade 3D printers can't print that because they're limited to about 230 degrees or lower, and that's really not warm enough to print a print like this for my car, or I wanted a stronger hinge, or I wanted something that was relatively clear, really translucent. And one of the advantages of the ColorFab XT filament is that this filament, and in fact PETG across the board, is available in clear. Now, depending on your infill and exactly how your geometry is set up, meaning how the object is defined, it won't print clear, but it will absolutely be translucent. So what's my conclusion? When I first heard that they were going to have a new 3D printer with an all-metal hot end, I thought that would be a higher-end 3D printer. Then I heard it wasn't going to have an LCD screen, it only had a single Y-axis belt. It was going to be smaller. And I thought, I'm not sure where this fits. Then I learned that it was going to sell for under $400. I thought, well, maybe. Then I used it. And I will tell you, the phone-based user interface, the integrated slicer, the ability to print in PETG makes this one of my favorite entry-level 3D printers. So if you can afford approaching $400, this printer will do things those other printers will not. And so I have no trouble at all recommending this printer as a good first printer, a good printer to use in an educational setting, in a library, in a small business. Folks, thanks for watching. I hope you enjoyed this video, and let's continue to learn things together.